Right, so the stream is on. Today I'm going to do some live experimenting, actually some theoretical experimenting for some things that someone is working on, and I'm very curious if I can do partially the same thing as he is doing, but then from ZX Spectrum Basic. I'm going to show you that in a minute. First, let's see what I want to show you. I think it's best to just open up the document that I've downloaded here, or actually it's in a browser. And it's about modern individually controllable LEDs, which are very nice RGB. You can call them LEDs, but they're actually free LEDs with a very small, very tiny microcontroller inside the LED case, and still the LED is with the free LEDs and the microcontroller is less than 1 by 1 centimeter, so it's very small. It has 6 pins and only uses 5 of them, and I'm going to show you what you can do with it. But first, let's put on some music, because we like music. Hope it's not too loud. Let's see if everything is working for the people who want to see that now or later. Yeah, hey Darren, you're watching. Yeah, I know exactly. I've been looking at these parts as well, and I knew you were using these ones, but I think there are two well-known programmable LEDs around. This is one of the two, and what I wanted to show is actually where you can buy them and how they look like. So LED individual strips, something like that. Hey Thomas. And of course I'll always buy these things in China because they're a lot cheaper there, real lot cheaper. I actually bought some earlier today. These ones, I think, and they're only just over €1 for the cheapest one. So, for example, the non-waterproof 1 meter with 30 LEDs, white or black, black one. I think I like the black one. So the one at the right side of the photo, because if you, for example, would like to stick these on the ZX Spectrum Plus case, the bottom part of the case, of course, then you can just put them at the outside of the case. What's that sound? Put them on a computer case with the self-adhesive tape, which is on already, and I think it will still look decent. But you can use them on the ZX Spectrum then. Yeah, maybe they're even cheaper on AliExpress. But look, this is only €1.28, so it's really not expensive. I think I will put the music a bit down. I don't know if it's too loud, but I think it's a bit loud here, but that's of course my amplifier. Anyway, let's see. So this is what you can buy with the same with the well-known LED with the microcontroller inside, and it's really nice part. And again, I was referring to someone who is working on a very cool gadget with these LEDs. But what I wanted to use, what I wanted to know, sorry, is it possible to program these LEDs from a ZX Spectrum by BASIC? Because the most important detail of the programming these is the speed at which you have to program these, and this is one clue. It says that should be programmed at 800 kilobits per second. So that's a lot, 800,000 bits per second. It's a lot for BASIC, I think. And there's even more information here about some timing details. For example, it says the TO high. And so when you send a 0, the high time should be about 0.35 microseconds, which is a very small amount of time, of course, with some margin, but not much. And that's the smallest time for creating the signals. So I was wondering if you can do that from BASIC. And my first guess is no, it's not possible. You need something like some machine code, so assembler code, which is maybe an even better way of trying to program these without external microcontroller that could do the job for you. But if you would do this from, for example, from machine code, you could have a machine code routine running in the background. I mean, as an interrupt routine in the ZX Spectrum, which is fired up 50 times per second, and the routine can send the data, which is stored, for example, in some memory of the ZX Spectrum. So that would be an alternative to trying to do this from BASIC. But if it would work from BASIC, it would be awesome. Well, I think you don't need to maintain 800 kilobits per second, because I think if you don't send any code, it will not do anything. I think it will just leave the LEDs as they were programmed the last time, if I'm not mistaken. So I'm hoping you don't need to refresh the same data all the time. If you would need to do that, then this will definitely not work, because any delay in BASIC will ruin this. You have to maintain it. The single command for the whole length of the string. So you have to repeat it continuously then? You have to continuously send the same data if you not changing the data itself. Oh no, okay. Anyway, what I wanted to try, so I'm going to fire up Fuse here, one of the well-known emulators. Oh, that was a mistake. Alright, so you got Fuse, and what I want to do, what is it doing, man? It's getting crazy here. Maybe it's OBS that in the background that's ruining it. What I want to try is, I want to start a counter and see how fast it can count. And BASIC without any delays. So let's say the maximum speed possible. So let's do a simple counter. Well, let's do for an X loop, so we can see how long, for example, 1,000 iterations will take. Of course, this is not as fast as just increasing the variable, but and this will not take very long, but we can do some math with this data, I think. If we just do next A, what we'll get? We need some out command, I think. So let's do out 251, comma. Let's do something. Okay, 20. Delete. 50 next A. So we're going to send one byte to an I/O port with this command out. And if you want to control 30 LEDs, you must remain at 800 kilo for the whole 30 dataset. Yeah, okay, so what you mean is if you are programming all 30 LEDs, you have to send all the data continuously, so the 30 LEDs and then 25 bits for each LED. So I'm not good at calculating in from my head, so 30 times 24 is so 720 bits you have to send by an out command each, I think. There's no other way. At exactly the same speed. Yeah, of course. That's what I read in the documentation myself. So, okay, that's no problem. So you have to send continuously all the 30 LEDs. Otherwise, I guess if you only send one LED, then the rest will stay off. Am I right? So if you only send one stream of 24 bits, so for one set of RGB colors, then only the first LED will respond, I guess. I don't know, I'm not sure. But I think it does. Oh no, you say no. That's what I read from the manual, or from the datasheet. But anyway, this video is, I'm trying to stay in the state previously. Okay, but if you haven't powered on or sent any data to the other LEDs, I think they will stay in the reset state. Am I right? I think so. Anyway, I think we're on the same level here. So anyway, what I'm trying to do is I'm trying to find out if basic will be quick enough. So what I want to know is let's see if we can do this. Oh, where's Fuse? Where's Fuse gone? Anyway, here's Fuse. Alright, let's see. I don't think this will take long. This is a real speed, 100% speed of the original Sonic Spectrum. A couple of seconds, is it 10 seconds? About that, I think. Alright, so what I want to do is run it. I will make it myself more easy. So we do 5 border 2, pause 100, 100. Then we do 60 border 7, border 2, pause 100, border 7. Then so we get a start. We start with border 2 and we end with let's say border 1 then. And of course we have to change the border to white in the meantime. So when it drops to white, let's make it yellow. That's when it changes to yellow. So 2 is for the start. When it changes to yellow, I have to push the button here. And when it changes to blue, I have to push the button again, and we can see how long this will take. And if it's any use of oh, I was a bit late. Okay, so about 7 seconds. So let's get a sheet here. So we have 7 seconds. So we have 7,000 milliseconds. Let's see. Let's do it in a better way. So, but this is for 1,000 iterations, 1,000 out commands. Oh, 1,000. And what I want to know now is how long will one out command take. Now that's easy, of course. So one out command will take 7,000 milliseconds divided by the 1,000 out command. So 7 one out command takes 7 milliseconds. That's what we know. So that's the first. 7 milliseconds. And what we needed was, let's remove this, and let's remove this. And what we needed was a time of, we need 0.35 microseconds. Oh, microseconds. Which is another unit, of course. And you can see here that it's definitely not fast enough, because we need microseconds and we're on milliseconds, because 7 milliseconds is actually 7,000 microseconds. So basic is completely unusable for this. So to be exact, this is 7,000 microseconds, and we need to time the routine in 0.35 microseconds. So you see that these LEDs really need a way faster method of sending the data. So the only way we could try doing this is by machine code, and now I'm thinking how could we test if that would be fast enough, because that will be a lot harder, and I'm afraid it's really not simple. let's see. Yeah, of course. So you should always send all the data for all LEDs at one time. Otherwise, you don't know what the state will be at when you switch on the LEDs. All right. So basic is definitely not an option. So one iteration took 7 milliseconds, and we need microseconds. So it's way off. Well, what we know is we have a ZLE CPU. Let's put it on this side, and we can. This is basic. Now let's go to machine code. What we know is we have the CPU that runs at a high frequency, of course, and of course one clock tick will not process exactly one machine code routine. Let's see. A machine code. Let's see. Wait, just a second. So we have 3.5 megahertz, and I have to check how many T-states you need for what I want to say one iteration, but I should look up how long an exact out operation will take, and at the same time fetching the data from memory and that sort of thing. How long that will take, because you have to create an exact data stream. You have to create an exact data stream. Let's enlarge this a bit. You have to create an exact data stream with taking all the data fetching in mind. So that will be hard, but I don't think it's impossible from basic, from machine code, of course. So what I want to know is, in freewheel, let's say, well, maybe we can check a bit here. For example, Z80 T-states. There's of course somewhere a page that shows all the T-state length of the commands. Instruction set. There's nothing here about T-states. No, I'm not using this a lot. Okay, this is something about the T-states, which could be useful. I think these are T-states. Yeah, the second column here. Oh, it was sorting. All right. Well, for example, if we just do an out command, there are several out commands, of course. But for example, you want to do an outc, a, for example. That's one of the most used ones. It will take 12 T-states. It says here. Maybe a bit more when you fetch them. I'm not sure. I have to check what exact T-state length would be. But let's put that in our document here. So 12 T-states. And I even don't know because I never looked it up if 1 T-states equals 1 clock tick. I don't know. But just for my ease, I would think that it would mean that you have 3.5 megahertz. So I would say 3.5 divided by 12, and this is of course, because I'm using Dutch Excel. Mega commands per second, something like that. So if we would then say is this one by, then we have commands per sec, maximum speed. But we need, of course, a couple of commands. So. Well, what can we do? I would say let's make it 100 T-states then. So this is about what we can do per second, and I don't think this is for real, but because again I don't know exactly if T-states equal to number of clock ticks per second. I have no idea actually. But let's get back to the Excel. If we could do this, would this be quick enough? That's the question. So What can you do in, what would each command take? Well, each command will take these seconds. So how many microseconds is it? It's this 1 million. This is microseconds. I think it will take 28 microseconds. Am I right? I think so. Let's check it out again. So we have 45,000 commands a second, and each one will take 2.8 to the power of -5. And in microseconds, that is 28 microseconds. And it's way too long, as you can see here. So we need a speed of, we need to create signals with a maximum length of, or minimum length of 0.45 microseconds. But the minimum length we most probably will get is something about somewhere around 10 or 20 microseconds. So I guess this is way too slow from machine code as well. So I don't think this is a real solution for driving these individually programmable LEDs from basic or machine code. I don't think either of these is an option of solving that. So we need something that's faster, and the only solution for that will be a microcontroller or FPGA. Exactly, FPGA to send the data at the speed the LEDs need. And actually, I think it's a bit of a pity that they chose to have this high frequency of data stream, because why not also allow the data to be sent at lower bitrate? Because why not? Why this high frequency? I have no idea. Anyway, because it would save power, I would guess, because the microcontroller inside the LEDs would not have to run at the high speed. Even better, I would think, would be if you use something like a strobe command. So every bit will get latched by an external strobing signal, like on all parallel ports. But it's not done that way. It's you have to feed 800,000 bits per second. So it's not the easiest way of sending data. So it's really aimed at modern machines like Arduino or Raspberry Pis or something like that, which can send the data at the correct speed, of course, because these things run at a couple of hundred megahertz or gigahertz, for example. I know, I know, Xelior. Xelior. It's just that I was really hoping that you can do some experimenting from basic or machine code, but it's really, ZX Spectrum is not fast enough, you know. So I think it's a bit of pity, and we'll just have to live with it. We need an external microcontroller which does the job for us. So I will look somebody in his eyes and ask him on my knees if he can continue working on his experiments himself. And we have to wait until he is getting along with that. And I'm not pushing him at all. I was just sharing my thoughts, and you chose yourself to respond to this video. So anyway, that's it for now. I was just doing some out loud thinking. I really hope to see a new product which would really suit the ZX Spectrum, because if you have a ZX Spectrum, why not have RGB colors on your ZX Spectrum in the future somewhere? So I just got a nice message that this Friday on a Byte Light Weekly Show there will be some cool new things to see about this experiments we're doing. So I hope we can have something to show you this Friday on the Byte Week show at 6 o'clock UK time, 7 o'clock Dutch time. So guys, thanks for watching for this short video, and I hope you liked it, and we'll do lots more of these in the future. Bye! Head over to zxspectrum.shop to buy brand new add-ons for your ZX Spectrum. Lots of different products are available, for example the ZX HD HDMI interface, or the DiffMC Enjoy Pro 1 SD card interface, and lots more. Set a currency preference to British pounds or euro, and check out easily. Also found on our website are links to our Facebook page with weekly updates of all kinds of ongoing projects. And of course, do subscribe to our YouTube channel with lots of reviews and the Byte Weekly Show episodes.